Hey, how's it going? So in this video, I will be going over um, some updates. This will be like a learning session because we had for Pencil Bible, Christian from Margello come in and um, help us with some advanced issues, or at least advanced from my expertise and understanding. One of them was that previously we had to physically limit how much of a person can draw on certain chapters. So take this one, ES3. It's ES3 Bible translation. We're in the Numbers book, chapter 3. Um, we can see that it's very relatively short, right? There are some chapters, especially in Psalms for I think it's TPT, the Passion Translation. I think that was the one. Like Psalms 119 is massive. Like it's so long. Um, the rendering the text was fine. The issue was with the Skia canvas. The issue is how we were approaching it. First of all, that's the issue. But the bug that we were, or the crash that we were running to was due to um, our usage of React Native Skia. Um, I'm definitely butchering this. Christian gave some insight into this, but the general idea behind the bug was that the canvas behind the scenes uses like some graphics thing and graphics card or something like that processor. I have no idea. There and there's a limit to like how much the size of some piece of data or type of data or how fast it's moving or something like I said at that level. But there was some limitation with something to do with the graphics environment of the device, which is the iPad that the user is using Pencil Bible on. And our approach to it was competing with that limitation. What Christian did was switch up how we are using the Skia canvas so that we're no longer competing with this graphics card. What we were doing was the canvas, right? What you could draw on versus the text. What you could draw on was just the canvas was growing the same height at with the height of the chapter of the text. And like I said, for some of those big chapters, Psalms 119, um, we were going to hit that max. What we're doing now is, and what we were doing was with that as well is our annotations were based on I don't know if they switched this part, but our annotations were based off like an XY coordinate on the screen, meaning that up here to the left was 0, 0. We would go down, you know, there'd be a max horizontal, but then width can grow and grow. Um, I know they were talking about fixing. I don't know if they did that in this one. We'll find out. But um, but yeah, now I believe, and like I said, we'll figure this out. But now I believe that um, the canvas just stays the same size. So the canvas is never bigger than this screen here. Um, it's just that like the canvas body is moving around. The border is staying the same, but it's like we're moving a magnifying glass around the canvas that's like way bigger than um, not really on the width side. I guess eventually it could be, but it's way bigger going down than what's being on the screen. So yeah, we're just kind of moving the glass down. Um, I'm pretty sure that's what we're doing now, but we'll go ahead and, like I said, check that out. Why I want to create a video is just to document kind of like my thoughts on just learning, not really my thoughts, but just like how I'm going through and learning and adding documentation. Um, give a shout out to them. And yeah, I mean, I just don't know. We got into like Christian did a bunch of reanimated stuff, React Native reanimated. Now, to be honest, I'm super ignorant to this stuff. I've stayed away as much as I possibly can. Um, but in order, and I would like to still do that. But in order for me to find someone internally for Pencil Bible that can pick this stuff up and manage this stuff, and not just one person, but a collective of people, anybody flipping onto this has the tools they need to succeed. It needs to be documented. It needs to be documented. It needs to be, um, you know, yeah. I mean, that's really it. Tested and all that stuff. So I'm gonna go ahead and do that. And yeah, sweet. So let's see. The first thing that's different is, and I guess I don't need to even show this, but let's see. Let me, I guess, just kind of go through and see what comes across. So the first thing is that we have this reanimated dot scroll view now. Let's see. I wonder if we can do get lens and file history. Compare with head. How do I do? I would love to do that. Compare. How do I? It's got to be a way to open this. Sorry, the glare in here is a little tough. Definitely need to figure out the light situation. Yeah, that's way better. How was I trying to get around? It's got to be some way to like view. Oh, this one's a big one. So animated. Okay, looks like we had animated though. But what's reanimated? React Native reanimated. Okay, so it's just a difference. So what's the difference between animated versus React Native animated? Maybe this tells us. It's no longer actively maintained. Nice. But what was I looking at before? Use animated reaction. Sweet. Okay, so use the latest version. Getting started versus about. It's got to be some motivation somewhere in here. React Native apps, the application code is executed outside of the application's main thread. This is one of the key elements of React Native's architecture and helps with preventing frame drops in cases where JavaScript has some heavy work to do. Unfortunately, the design does not play well when it comes to event-driven interactions. When interacting with a touch screen, the user expects effects on screen to be immediate. Okay, it makes sense. If updates are happening in a separate thread, it is often the case that changes done in the JavaScript thread cannot be reflected in the same frame. In React, I don't understand that part. In React Native, by default, sorry, I'm here. In React Native, by default, all updates are delayed by at least one frame as the communication between the UI and JavaScript threads is asynchronous, and the UI thread never waits for the JavaScript thread to finish processing events. Okay, this part's confusing, but I'll keep going. On top of the lag, with JavaScript playing many roles like running React diffing and updates. I think React diffing is just determining should this component be re-rendered or which part of this tree should be redrawn. Um, on top of the lag with JavaScript playing many roles like running React diffing and updates, executing apps business logic, processing network requests, etc., it is often the case that events can't be immediately processed, thus causing even more significant delays. Okay, so let's try this whole piece again. So we get that when you touch the screen, it should happen right away. We get that. And by this point, we know that the application code is not in the main thread. And JavaScript is on the main thread. Okay, so let's see. If updates are happening in a separate thread, so it would be nice to know if JavaScript, like it, maybe that's what we're about to get into, but is this on the main thread? What's an example of the application code? Okay, so if updates are happening in a separate thread, it is often the case that changes done in the JavaScript thread cannot be reflected in the same frame. It just makes sense, right? Things exist in two separate places. It's going to take some amount of time to get from point A to point B. In React Native, by default, all updates are delayed by at least one frame as the communication between the UI and JavaScript threads is asynchronous, and the UI thread never waits for the JavaScript thread to finish processing events. So the UI thread listens, reacts. I'm sure it sends a message to the JavaScript thread. JavaScript stuff is executed and then returned somewhere. But by this point, the UI thread has already moved on to the next stage, so it's like updating it afterwards. I think that's kind of what we're dealing with. On top of the lag, with JavaScript playing many roles like running React diffing and updates, executing apps business logic, network requests, etc. So on top of the lag with JavaScript playing many roles, it is often the case that events can't be immediately processed, thus causing even more significant delays. Okay, so it's just saying that doing network requests is longer. So doing network requests takes time. Messing with data, retrieving data from the database, that all takes time. And a lot of times the UI is, the UI is dependent, but it seems like the UI thread just does its own thing, so it's not actually dependent. But from a user experience standpoint, it is dependent. So yeah, it's just saying, I guess it's just saying that. Reanimated aims to provide ways of offloading animation and event. Where'd it go? Offloading animation and event handling logic off of the JavaScript thread and onto the UI thread. Okay. This is achieved by defining reanimated worklets. A worklet is a tiny chunk of JavaScript code that can be moved to a separate JavaScript virtual machine and executed synchronously on the UI thread. This makes it possible to respond to touch events immediately and update the UI within the same frame when the event happens without worrying about the load that is put on the main JavaScript thread. So is the application's main thread, is this the main JavaScript thread? Or is this a different thread? And then there's multiple JavaScript threads, but then there's a main JavaScript thread. No idea. This is achieved tiny chunks of JavaScript code that can be moved to a separate JavaScript virtual machine and executed synchronously on the UI thread. Okay, sure. Version 1 of Reanimated has been designed to match React Native's animated API while providing a more complete set of primitives for defining interactions. In version 2, we decided to change the approach in order to address some limitations of version 1 that came from the declarative API design. Below, we present an overview of things that are new in React Native Reanimated 2 and different from 1. This is a TLDR of the remaining parts of the documentation. Okay, I think we're good without that. All right, so let's go see what the actual updated version looks like. The goal of the fundamental section is to help you gain a strong foundation of the core concept of Reanimated, to give you the confidence to explore more advanced use cases. Install the package, plugin. In short, the Reanimated Babel plugin automatically converts special JavaScript functions called worklets in a way that they can be passed and ran on the UI thread. Worklets are short running JavaScript functions that can be run on a UI thread. They can also be run on a JavaScript thread just as you would have run a function in your code. Most of the time working with Reanimated, the code is automatically workletized to convert a JavaScript function into a serializable object that can be copied and ran over on UI thread. Function marked with worklet directive are automatically picked up and workletized by the Reanimated Babel plugin. Most of the time, you create your own worklets using worklet. JavaScript thread, or JS thread for short, is responsible for handling JavaScript code execution in the app. This is the primary place where the React Native code is executed. Okay, so that's more simple, I guess, than the last one. That's a nice logo. UI thread is responsible for handling user interface updates, also known as the main thread. Okay. You can learn more about it by reading the threading model article in the official React Native documentations. Okay. React Native renderer distributes the work of the render pipeline across multiple threads. Here we define the threading model and provide some examples to illustrate thread usage of the render pipeline. Threading model and provide some examples to illustrate the thread usage of the render pipeline. React Native renderer is designed to be thread safe. At a high level, thread safety is guaranteed by using immutable data structures in the internals of the framework. This means that every update in React creates or clones new objects in the renderer instead of updating data structures. This allows the framework to expose thread safe and synchronous APIs to React. Every update in React creates or clones new objects. I don't know how that makes it thread safe, but I don't know. I need to know. The renderer uses two different threads. UI thread, the only thread that can manipulate host views, so that the UI, and this is JavaScript thread is where the React's render phase as well as the layout are executed. The supported scenarios of execution for each phase, event, render, layout, commit, mount. This is the most common scenario where most of the render pipeline happens on the JavaScript thread. Event, render, layout, commit. Render in the UI thread. When there's a high priority event on the UI thread, the render is able to execute all the render pipeline synchronously. This scenario shows the interruption of the render phase. I don't know yet. We need to do the rest of that. Okay, that didn't really need that. The plugin performs automatic workletization of certain functions used with Reanimated to reduce the amount of boilerplate code. You can learn the details by reading that. Okay. So let's go here. So use animated reaction allows you to respond to changes in a shared value. It's especially useful when comparing values previously stored in a shared value with the use animated reaction allows you to respond to changes in a shared value. Shared values are a driving factor of all your animations in reanimated. They are defined using the use shared value hook and accessed by the modified by their dot value property. Okay, so it's just like a reference. It can be the value of any type. When used, the data stored as shared value is automatically synchronized between the two. Okay. So a function, okay, so use animated reaction takes in a function which returns back sv.value. Okay, let me go back here. Allows you to respond to changes in a shared value. It's especially useful when comparing values previously stored in the shared value with the current one. Okay, so when there are changes to the shared value, you have the new value and the previous value. That's what this is. And you can do the things. But I don't know what's up here. What this first property is, prepare, I guess. Arguments, type definitions, prepare. Okay, yeah. So a function that should return a value to which you'd like to react. The value returned from this function is used as the first parameter of the react argument. A function that reacts to the changes in the value returned by the prepare function. The react function has two parameters, the current value from the prepare function and the previous value, which is initially set to null. An optional array of dependencies go where? Okay. Use animated reaction returns undefined. Okay. Example. We have use animated ref. Use shared value. Use state. Handle press. With spring is I'm sure some yeah. Some animation stuff. Use animation reaction, which is going to change when with dot value changes. We're not going to do anything with dot value, but it has changed. It has changed because of this. So what we're doing is taking the measurement. What's measure? Measure's another thing. Taking a measurement of the animated ref. If the measurement is not null, then we are getting the width, which is parse int, taking the width, run on JavaScript set text, measure width. So I'm hitting the button. Click me is handle press. Width dot value is changing. Width is changing. I mean, we're setting width up here, I guess. So that's changing this, which is changing the width of this entire view, which is changing the measure value of the view. The measurement stuff. And then run on JavaScript. We'll figure that out. But ensure you do not mutate the same shared value in the result function that you use in the prepare function. I see, I see, I see. Okay, sounds good. All right, so what about run on JavaScript? Lets you asynchronously run non-workletized functions that couldn't otherwise run on the UI thread, as applies to most external libraries as they don't have their functions marked with. It's usually used to update React state either on animation finish or conditionally within a gesture. So function takes in an argument. I'm pretty sure this just means like this is a function that returns a function. So we're passing args. Let's see. A reference to a function you want to execute on the JavaScript thread from the UI thread. Arguments to your function have to be passed to the function returned from run on JavaScript. Yeah, I'm pretty sure that's what this means. So this is this function. It ends up being this function, so we have to rerun it. I don't know why we have to do that, but I don't know. Yeah, I don't know why they do that. Functions passed on the run on JavaScript must be defined in the JavaScript thread scope, hiding the component body. This code doesn't work because my function is defined in the with timing callback, which is only executed on the UI thread. It's a common mistake to execute function inside of common mistake. Oh, here's the correct usage. Safe to run a function. Okay, so yeah, I don't know. It's a function that returns a function, but yeah. Okay, so I got a lot more info now. So we now looks like animated and reanimated are just the same thing. Reanimated is just better, right? So we get more things. So we have a scroll handler. We had it inline. Now we do not. So let's go ahead and check out that scroll handler. We have a scroll handler, which is use animated scroll handler. This page reported from an old version of documentation. As we're rewriting documentation, some of it might be outdated. This is a convenience hook that returns an event handler reference, which can be used with React Native scrollable components. Use animated scroll handler. No, I want to. Oh, where'd that go? We're passing it an on scroll of scroll y dot value is equal to the y. Scroll y now like a shared value or something. Oh, it's right here. Yeah, shared value. Okay. So let's see. Scroll handler or handler's object. Object containing any of the following keys. The values in the object should be individual worklets. Each of the worklet will be triggered when the corresponding event is dispatched on the connected scrollable component. Each of the worklets will be triggered. Okay. Each of the event worklets will receive the following parameters when called. Event object carrying the information about the scroll. The payload can differ depending on the type of the event. Context, plain JavaScript object that can be used to store some state. Plain JavaScript object that can be used to store some state. This object will persist in between scroll event occurrences, and you can read and write to any data to it. The object will persist in between when there are several event handlers provided in a form of an object of worklets. The context object will be shared in between the worklets, allowing them to communicate with each other. The hook returns a handler object that can be hooked into the scrollable container. Note that in order for the handler to be properly triggered, you should use containers that are wrapped with it. Okay. The handler should be passed under the onScroll parameter, regardless of whether it's configured to receive only scroll or also momentum things. Okay. Looks like we're just using that. Sounds good. Okay. But then where is scroll y.value being used? Using these things, right? Excuse me. Gotta figure out what they do. Okay, so we previously had scroll view styles. Scroll Y was what before? It was just a use state with an animated value. But now it's a use shared value. So I'll bring this up. Oh, I guess I can't do it, but I'll refactor later, I guess. But use animated reaction. So use animated reaction is going to react to when scroll y dot value is changed. Okay, I think I can take over from here. I'm actually gonna go heat up a coffee, and then I'll be back. But gotta find this stuff first. Not this. I want the reader. Sweet. Sweet. Okay, I'm gonna pause this. I'll be right back. Okay, back. Sitting down now. Sorry, definitely did that before I unpaused, but sorry. Okay. So I got this document. This here document this. All right. When the scroll y dot value is changed. Oh, excuse me. We need to determine if the user wants to scroll backward or forward. Back to the previous chapter or forward to the next one. 1 second. My vent was open and my cat loves to, like the lid was off. Cat loves to do stuff like fall in there. Definitely don't want that. Okay. So this gives us back current value and previous value. So I can also do previous value. And that gives us, yeah, the previous value. It's, I think, null by default. Maybe like on the initial run or something. She loves sitting on a little poof. And when the value is changed, we are checking and then going back or forth. So what is this? So what does this mean? This means that on the JavaScript thread. Wait, I thought we couldn't do run on JavaScript inside of there. Use animated reaction. Oh, we can't change it. That's what it is. Okay. And I thought it was something to run on JavaScript though. Didn't it say something about because my function is defined within the callback, which is only executed on UI thread. So with timing is on the UI thread. So on the JavaScript thread, we are setting pagination going back. Why are we doing this on this thread? Because the UI thread has to react to the touches and the scrolling and stuff. So we're passing this to the JavaScript thread because it's asynchronous and it's just going to happen when it happens. But we still want the UI to keep going. Is that what it is? I think that's all it is. Because if we are, so we're scrolling, when scrolling changes, we're checking the current value. If it's less than 150, you know, we're going back. I don't think the scrolling was like the UI was changed much. Sorry, the UX for the scrolling. I don't know. Let's see. Just asking Aaron about it. This is Christian. Okay, so then we have the styles, which do the same thing. What's interpolate do? I know we had that before. I don't know what interpolate does. Sometimes you need a map. You need to map a value from one range to another. This is where you should use the interpolate function, which approximates values between points in the output range and lets you map a value inside the input range to a corresponding approximation in the output range. It also supports a few types of extrapolation to enable mapping outside the range. The value is a value from within the input range that should be mapped to a value in the output range. So I think it's like you have a range of numbers here, you have range numbers here. This is the input. Can you see my hands? Yeah, this is the input here. One of these values, you should be able to provide a value in here or select one of these, and then it maps to one of the values in here. I think that's what we're saying. Array of floats that contains points that indicate the range of the input value. Value should be increasing. Should have at least the same number of points. Excuse me. Can be either object or string. If an object is passed, it should specify extrapolation explicitly for the right and left sides. If extrapolation for a side is not provided, it defaults to extend. If a string is provided, the provided extrapolation type is applied to both sides. Available extrapolation types .clamp clamps the value to the edge of the output range. Identity returns the value that is being interpolated. Nice. Aaron said it's faster, so like the actual like the Yeah, I think there was also like it would like kind of do like a jolting thing. Yeah. Okay. Yeah, I just think it, yeah, I think it wasn't as like smooth. So it's just like it goes down and leaves. Yeah, before it was like sweet. Okay. Returns the value that is being interpolated. Extent approximates the value even outside the range. Interpolate returns the value after interpolation within the output range. Okay, so we have interpolate, which is a value. We have minus 100 and 0 and 2 and 1. Extrapolate right is clamp. Scale, scale. No idea what's happening here. Maybe I do in our case. So opacity. If the scroll value is negative 400, which I think is this way. Okay. So if we get to negative 400, we're going to give it an opacity of 0. Minus 185. Minus 205. Minus 205. Okay. Control. Let's scroll. Okay, yeah, I think we can just test this out. $388 is okay. So let's try that again. Okay, so it's 530 right now. This first one is I can't point to it because I have the screen here. 388 is this one. Let's just stick with that. Well, 382 is that first one. So that would be 468, 462. 682 is that last one. So we got 320 now. So if minus 400 is equal to 0. If you look at line 359, that minus 400 is going to be associated with 367. So I think what that means is if there's a value around minus 400 and it like rounds to it, then it'll give it an opacity of 0. Excuse me, if there's a value that is minus 300, it'll give an opacity of 0.1. If it's minus 100, it'll do 0.3. So it fades out more as we get more on the extremes. I'm pretty sure that's what it does. And it looks like we never go above. So I don't know if we need all of these values in the interpolate, but okay, that makes sense. Interpolate makes sense now. As the scroll y dot value changes, we want to change the opacity of the text. The more away from 0 we scroll, the more transparent from rest. Yeah, I think 0. Okay, so then the transform, what are we doing here? So transform, translate y. What's the translate y of transform? Translate y function repositions an element vertically in the 2D plane. Its result is a blank. So I translate y. Nice. Okay, so translate y goes down. I guess that makes sense given how Canvas works. So when translate animation changes, let's translate and animation. Translate and opacity animation value for changing chapters. Where are we doing dot value equals? All right, so we got transition page. Scroll drag has ended, which is, yeah, when the scroll drag is done, at this point, pagination and the pagination direction is going to be set because as we are scrolling, we're changing the scroll y dot value. As the scroll y dot value is changing, we are determining if we should or should not paginate when the user stops scrolling, right? So we can't notice, like, ideally if I go back to here, we're not going to scroll back, but if I let go, it's going to scroll. That's because we are already triggering this to call once we get down to minus 150, right? So right, because let me see, I got 8 minus 61. I feel like it's got to give me something. Minus 132. Oh yeah, I got close there. Minus 151, right? You saw how that jumped. Now we're gonna animate. So by this point, yeah, we already have set pagination direction. So now we're here. So now we're going to call transition page, which is going to do the actual transition for us. So run translate and opacity animation. Start by running THW. Supposed to be I'm guessing. Start by running the translate animations value to -1. Translate animation value. What is using this, I guess? Let me first see that. So this is the transform. Okay, so this is what's actually doing the moving. Now the other stuff just flops in. That's the next stage, right? Is getting it to disappear is fine. Getting the other stuff to scroll in from the top would be the fancy stuff. Is if the next chapter show also animates in instead of flickering. do that after this update. Okay, yeah, so that'd be cool. Maybe that's something I can. I'm pretty sure that I can do it. We'll see. There's still a bunch of words that I don't quite get in here. So yeah, we'll keep going here. Okay, so let's see. So with secrets. Okay, so where is this? This uses a transform. Okay, so this is saying move it up and down based on something. And same for opacity. Where's opacity that value? So we're not actually using this anywhere. So it's just a number. Okay, we're using it in a bunch of other places, I guess. Okay. For the annotations. Okay. Okay. All right, so what is with sequence? There's got to be something here. With sequence is an animation modifier that lets you run animations in a sequence. A sequence just one after another. Function app sv.value equals with sequence with timing with timing. I think we have with timing in here too. Yes. So what is with timing? With timing lets you create an animation based on duration and easing. Easing is what? Easing functions specify the rate of change of a parameter over time. Objects in real life don't just start and stop instantly and almost never move at a constant speed. When we open a drawer, we first move it quickly and slow it down as it comes out. Drop something on the floor and it will first accelerate downwards and then bounce back up after hitting the floor. Okay. I don't think I need to dig into that. So the code for this is what? So use animated style, translate X. We're using offset dot value. We're starting it at 200. So 200 is over because X is over here. So use effect offset dot value with repeat. Animation modifier. Let's repeat an animation given number of times to or run it indefinitely. Takes in what? Number of reps. It's also undefined, so I imagine that we can just not provide it to just always run. Okay. Where was I at before? That's with timing. All right. So with repeats, negative. I guess -1 is unlimited. A non-positive value will cause the. Okay. Yeah. Minus offset value. So it's the opposite. So given an offset value, this is minus 200 with timing. Yeah, how does with timing work? Oh yeah, that's what we're looking at. It's funny. So where is this? So we have the duration. We have the easing. We have a couple different types. That's a config. So we have the to value. So we're going from 200 to minus 200. And it's taking 1500 milliseconds, so a second and a half to get to 200. What if can I change this? That'd be nice. So true is what? Is reduce motion. duration. Okay, so now with repeat has animation, number of reps, reverse, yes or no. Whether the animation should run in reverse every other repetition. So this means it should run in reverse after every repetition. So I think it's, if it was false, then it would go here, jump back, go here, appear back. I think that's what it is. It's gonna take longer now. Yeah, it's gonna be super fast. Yep. Don't need to worry about those. Easing in out. Just different types of stuff, I think. Okay. So with sequence is now we're with sequence. Okay, so animation modifier lets you run animations in a sequence. So move, move, move. Takes in, with sequence takes in reduced motion plus animations. A parameter that defines how the animation responds to the device's reduced motion accessibility setting. Any number of animation objects to be run in sequence. With timing 50. So again, what does with timing do? Create an animation based on duration and easing. The value on which the animation will come at rest. Minus offset value. Minus 1 is indefinite. So I guess how is this changed? Okay, so it's just run once though. Is equal to with repeat. We're running this indefinitely. Going from 200 to negative 200 and then back from negative 200 to 200 every 1.5 seconds. So at first we're going to 50. Oh, this is different. Let's see. Okay. So the offset is initial offset is 200. So we're starting way over here. Then we have with repeat, with sequence, we're doing these three things. We are taking the offset value, which originally is 200. We are now going to negative 200, where duration is 800 milliseconds, so 80% of a second. And we are doing easing cubing, which is relevant for this. Then what we're doing is we're going to 0. We're taking the same amount of time, and then we're going back to here. And then we're flipping it once we're doing it in reverse, or whatever that is. With sequence, with timing 50, with timing 50. So this is just changing the SV value to be that. Okay. Okay. All right, so let's try and pencil Bible-ify this. Okay. Oh, what did I do? With sequence. Okay, so we're running a couple things. So when we are done, Rocco, I get mistreated. I go. Maybe he'll come up. Okay, so with timing, if the pagination direction, if we're going back, then we're going to go to -1. Else we're going to 1. And we're going to take transition speed, which is 50. Then we're going to go to 0. And again, this is being used here. So we got -1, 0, or 1. And then we got height divided by 2. Height is going to be whatever the height is, 1,000 plus 4,000, whatever it is, 2,000. If we're at -1, that means that we're scrolling back. Get rid of this. If we're at -1s, that means we're going backwards. So translate Y for the scroll view. So it's going to move this down, right? Yeah, we're going to move the things, the scroll view down by half the height. Transform. What happens if we don't use this? Yeah, why do we need that? I'm pretty sure we just had it before. So I wonder. Oh no, I crashed it. Just responding, sending a message to Christian right now. Documentation and clean code. Curious about the transform property on the scroll view styles, which I'm going to open changes on remote to dev, not dev. And the transform, copy permalink, scroll view styles for the new reader. I removed this. I know it was in there before, but I was wondering if /y we needed this. Now that I'm a bit more versed in the fanciness, It seems like we don't need to modify the transform, the translate y, or am I missing something? Okay. Maybe it takes away a little bit of the shadow, like a little bit of the niceness. I don't know. I don't know. We'll see. We'll leave it in there. Wait for Christian to respond. But yeah, 1 second. I'm gonna go get Rocco. Okay. So where was I? Yeah, what was I doing before? I think just going through. I guess we're almost done. Oh yeah, let me get back into this. Okay, so we're going to see this, and we'll dig into this more once Christian responds. Um, but the opacity is used. This is used for this opacity. Okay. Yeah, I think that's what we want. That's good. Let's see if anything else has been changed. Right back 1 second. Sorry about that. Rocco is going crazy, so I had to take him on a walk. Or he just kept barking. Now I just did all them stairs. Oh my goodness. Should have waited down pause, but yeah. So we got the page translation transition. Okay. Yeah, I guess that's is transitioning chapters. Okay. I think that's it. I don't think he made any more changes. The opacity now uses the opacity. I don't know what's going on here. Just creating a new reference to it. That's definitely what that was. Okay, so MC, I don't think Christian responded. That's okay. Okay. What about this? Save the layout's outer contents so that we can use it to size the canvas. We are passing the scroll Y. Taking out the cannot draw alert. So this is what we had previously. Yeah, I don't need to show it, I guess. And then we're here. The scroll view height is a shared value. We are setting that. Okay, yeah, we're just, okay. Okay, now what about the canvas? So the canvas, we're now passing So let's see, this was changed for the smoothing. The on start. If it's not a shape, we are previous point ref.current is that. And then this is what's using the rounding stuff. So we're taking the X middle, which is the previous point dot current dot X plus half of itself, taking the Y half of itself. Then we're doing path dot quad 2, going from the current X and the current Y, or the previous X and the previous Y. This is now the mid, so we're drawing a rounded quad 2 to that. Quad 2, just from what Christian says, quad 2 React Native Skia. Quad Bezier curve. Quadratic. For 3 given points, a quadratic Bezier curve is a linear interpret. That's way too much for me. But I guess I'm pretty sure it just does the curve stuff. Path.quad 2. Yeah, I think that's all it is. Okay. Add TypeScript. It's okay. Reanimated shared value. No longer need the device part, which is good. Raw X. So the raw X is the position on the screen. The scroll Y is the offset. So if I scroll down here, the scroll Y is going down with it. So the raw Y, oh, we're drawing though, not annotating. Okay, so let me, I'll wait till I get to this point because it's going to be at the end. But we're just moving based on also what the scroll view is moving. Same thing for the Y. The X will stay the same. Okay, so this is the canvas container styles. The height, so the top should be 0 always. The height should have the same height as the content container of the parent scroll view. Am I muted? Am I still recording? Okay. Should have the same height as the content container of the parent scroll view. Okay. Props.layout.height. Layout is a layout rectangle. So we'll have to dig into what exactly what layout rectangle is. Maybe we can see based on the reader layout. It's an X, Y, and a height and a width. Okay. Now calculate width slash left as we previously did. Okay. Now let's translate. Move the annotation, move the canvas up or down. Okay. Transform. Create a transform for the contents create a transform for the contents of the canvas based on the scroll position. Create a transform for the contents of the canvas based on the scroll position. The translate Y is the opposite of the scroll view. And the transform does that. So if we're scrolling here, the scroll Y is going to be less than 0. But we want the annotations to move in the opposite direction. So that's why we're doing the minus here. Okay, I'll get to the refactoring in a bit. The documentation here. I guess I can do it here. So as the scroll view, as the user scrolls down, the scroll Y will decrease in value. Therefore, so we need to move the canvas, move the annotations down the screen by the same amount, which increases since x 0, 0, since the 0, 0 annotation coordinate is the top left of the screen. Okay. Sounds good. All right. Use derived value. What's that do? Use derived value lets you create new shared values based on existing ones while keeping them reactive. So I think it's just like a state. I think it just behaves like a state. So therefore, a state updates the UI, whereas a reference does not. I think that's what's going on. Okay. So group is what? Group component is an essential construct in React Native Skia. The group components can be deeply nested with one another. It can apply the following operations to its children. Paint properties. Its children will inherit all paint properties applied to a group. Transformations. The transforms property is identical to its Homonymus. That's so funny. Homonymous. Homonymous. It's got to be a homonymous. 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 That's funny. The transfer property is identical to its homonymous property in React Native. Except for one significant difference. In React Native, the original transformation is the center of the object, whereas it is the top left position in Skia. The origin property is a helper to set the origin of the transformation. Okay, sure. General idea. So we're just grouping it and applying a transformation to all of them. So this is what's actually moving the window. This is what's moving the window. Sweet. Okay. Oh, excuse me. Okay, what's up here? What does it say? Reverted debug commit. Direct. All right, sweet. So I don't fully think I understand all of it. So this is all the same. So the height, the top, the transform. This is what does the actual moving of the drawings. Okay. So now if I remove that, now we're back to scrolling. All right, so let's see here how this is working. So if I don't do this, it still works. Why? Canvas container styles. Okay, so I'm gonna create a video for Christian. Yeah, Loom does this all the time. Old, I thought it was just my old laptop, but it's wow. Why do we have all these? Why do we have so many? Didn't even know you could. Sweet. Thank you, Loom. Hey, what's going on? So I'm just curious on like what this is actually doing. Um, I I get the idea of it. I believe it's what moves the the canvas up and down. Maybe it's, let me try. Manage Bibles, create another Bible. Select translation. TPT. Skip. Psalms. Oops. 119. Use pencil. So I wonder if that's what's needed here. Where'd that go? There it is. Okay. So the transform is moving based on the scroll view. When did that get smaller? So that's what this is doing. Yeah? No? So it's drawing. I guess we need it. I don't know why refreshing crashes. See, that could just be an issue with like the fact that I'm re-rendering. I mean, it's not working here. What else did I do? What did I do? But now the scrolling's not working. Yeah, I'm pretty sure it's just like I'm messing with the things here. And that is what's causing the errors. But I think it's good. So yeah, I mean, I guess I am curious on exactly what this is doing. So this is transforming the canvas and moving the canvas around. But then we have transform, which is moving the annotations down if we go up. Move the canvas So we're not actually moving the canvas, we're moving the canvas container. And then we're also moving the annotations themselves. We need to move the container down because the scroll view is down. So let's say that this is like, I don't know, 1500. I think what that means is nothing's going to happen when I start to scroll stuff. Or was it that? All right, so what if I do, let me go to 119 first. So right now I have drawing on. So when I do this, it should draw, but it's scrolling. But if I keep pressing up more and more, eventually I'll hit a point to which I start drawing. I see. Oh, that's funky though. I think that's just because I'm messing with stuff though. That's funny. Yeah, it's definitely not a them issue. Okay. Canvas container up and down. The canvas container controls where the X and Y coordinates are relative will be registered as a touch by the canvas component. If you hard code this value to 2000, go to TPT Psalms 119, you'll notice that any touch events are registered as if the user is scrolling. If that touch.y is less than 2000. This is because the canvas is only available starting at the y coordinate of. But I think what that means, if I go down to here, it's going to be scroll as well. The height of the canvas is still the same as the screen height. Therefore, the canvas is does not recognize the receive touch events that are greater with our hard-coded value of 2000. Does not recognize / receive touch events that are greater than 2000 plus divide the screen height. Sweet. Very cool. Super long explanation, but it is important for sure. Okay. I think we're good. I think we're good. I think we have a good understanding. So let's run through that again. So we got new reader. This is in charge of not just the canvas, like spacing. This is in charge of calling the canvas, but it's also in charge of calling the text. Um, we have a layout. This layout gives us an x and y of 0, and it also gives us a width and height, which is used by the canvas itself. Set layout returns back. What? How is this value changed? I guess. So it's not going to be changed. It's going to be called once. Yeah, reloading crashes every time. Height width x y 0. Okay. Okay. Yeah, it just gets ran once. This screen is visited, and then that's going to be the size dimensions of the canvas. Okay. So we're setting the height and width of the canvas, and then moving it down as we scroll. Because as we scroll, these y values are growing, so we need to make sure that we're moving the canvas down those y values. We are transitioning the page. Um, translate, which is translating the transform for the scroll view. Yeah, we'll see what he says about that. We'll see. We'll revisit this later. I might not create a video for it. I do apologize in advance. Maybe I'll just tag it to this video as well as like a reply or something. But the opacity, where at least as we transition with timing, so transition speed, we're going to go to opacity 0, and then with delay, we are going to the next sequence run trans value to 1. I think this is supposed to be opacity with duration 0. Duration is pretty much 0 with duration 50. I think. I don't know. Maybe Christian wants those things back there, but run the opacity's value. Go back to with sequence. So sequence. How long is the sequence? I don't know. That's okay. But then the scroll handler, we are setting scroll wide value. This is then being used by the canvas itself to alter the drawings as well as the drawings as well as the sorry, I just had a thought. Canvas. Use animated reaction, which as we're scrolling, we are determining if we want to do the pagination. We could update this to also check that, like, if we first go down to 150, where we first go down to 150, but then we go back to here, prevent that scrolling. I don't think that's too hard to do there. And then, yeah, we're just working with the opacity stuff. Yeah, so it's pretty straightforward. Thank you, Christian and Co. on helping us out with this. I don't think there was any more changes. Okay, so let's do set. To be able to use the UI thread-based animations, smoother scrolling, etc., we need to make some preparations by upgrading and fixing REA and react-native-reanimated. Okay, so implement a fix with a canvas height limitation by using a fixed size canvas that covers the screen or the scroll view to be precise, and uses translations and a transform matrix to place annotations based on the scroll view's position. Upgrade, yeah, React Native, Reanimated, and Shopify to latest versions. Added patch package and patch for the pencil detection code in Skia. Now runs automatically with Yarn. Thank you. Added Xcode 15 fix to pod file. Fixing existing animations. Converted the existing scroll view back forward animations to reanimated since they were previously made with React Native animated. Okay. Please test that all animations are working as expected. It was a bit hard to understand the ones using opacity and translate anim also used by the chapters components. So, okay, so I think Christian message talks about this. Okay, so okay. Updating the canvas components. I gotta check the old annotation canvas. Change canvas style to use the layout height from the outer scroll view. Change canvas style to be translated so that is always fixed on screen. Okay, sorry. Change canvas style to use the layout height from the outer scroll view. Okay. Okay. Changed canvas style to be translated so that's always fixed on the screen. All right. Added skier group with transform that translates annotations alongside scrolling. Okay. Move the alert. Very cool. Boost 1.8x does not have the issue and built correctly. Would be nice to have a short comment explaining why so that future peeps don't rip it out knowingly. Okay. Pod file package, Shopify. Okay. Reanimated is good. Patch package, all good. So chapter.tsx, we haven't checked that. So chapter uses the styles for the animated view styles, uses opacity. Nothing crazy there. TPT chapter, same exact thing. Just uses opacity.value now, and nothing else is crazy. New reader, we went over that. Okay. Current annotation canvas, went through that. Old annotation canvas, I probably just does the same thing. Looks like it does. layout.height. Height is layout.height. I think the other one uses props.layout.height. Transform, same thing. Canvas, same thing. Okay. Sweet. Sweet, sweet, sweet. Cool. Yeah, now I'll open this PR, my stuff, to Christians, and then go from there. Sweet. So yeah, way better understanding of React Native Reanimated than before. I was so confused at all the things. Whew. Oh, stayed away from it. And yeah, cool. Thanks, y'all. Adios.